Hello, so today we are going to talk about the Poisson random variable. We had done the, we had, I think, let's select this, yeah. We had done, wait, let me just take this down here. Yeah, I think this is better, right? Yeah. So we had done the Bernoulli and we had done binomial. So now we will move on to next one, which is the Poisson RV. How are we going to define Poisson RV? First we need to know what is the probability function, that is pi is nothing but p x equal to I is equal to e to the power lambda to the power I by I factorial, where i's value will be from 0, 1 and so on. Okay, so this is the Poisson random variable. So initially whenever we are working with some random variable, we must see is it actually the probability mass function is correct or not. So we first have to do a summation from 0 to infinity pi, so that will become e to the power minus theta. See, this is a constant, by the way. Okay, this lambda is constant, so wait, e to the plus lambda to the power I by I factorial. So this thing is nothing but e to the power lambda, so this becomes e to the power minus lambda, e to the power lambda, so this is 1. So it's a PMF and this is correct. Okay, so this was actually done by the person named Poisson. The person who did this was named Poisson. And okay, so like this is the main thing that we are going to discuss about. So whenever we start with the Poisson ratio, the initial thought that we must have is what is the expectation and what is the variance. So let's try to prove that. So the expectation is what? Summation xpx or integration xpx, whichever. So I am going to consider this to be a discrete right now. So you have to realize something. Everything I will either be a continuous thing or a discrete thing. If it is a discrete thing, do a summation. If it's a continuous thing, do an integration. The answer is going to come same. So integration xpx. How do I deal with this? Okay, so x will be my I e to the power minus lambda I by I factorial. So this gets cut, this becomes I minus 1 factorial. So can we write this as lambda e to the power minus lambda to the power I minus 1 by I minus 1 factorial. So this is lambda only, because see this thing, this becomes the Poisson ratio again, right? So this is the Poisson RV, and when you do this summation is from minus to infinity. We know when this summation happens, its value is 1. So this value comes out to be 1. So the final, we find out that ex is nothing but lambda. Okay, now let's talk about the variance. The variance, we first find ex square. Ex square becomes summation of I square by I factorial e to the power minus lambda to the power I. Now of course you cut 1 here, so this becomes summation of I e to the power lambda I by I minus 1 factorial, right? So let's make this something like lambda summation I e to the power minus lambda 1 minus I by 1 minus I minus 1 lambda. We can do this. Now let's induce something like this, where it becomes j plus 1 e to the power minus lambda lambda j by j factorial. Okay, so I have induced something like this. Now we can break this down into this lambda summation j e to the power minus. So here you can see j is nothing but I minus lambda. I'm just doing the substitution here. Lambda to the power j by j factorial plus lambda summation e to the power minus j lambda by j factorial, right? So this is nothing but lambda and this is nothing but 1, because this is nothing but the PRV, so this becomes 1, and this is nothing but e to ex, which is lambda, so this becomes lambda square plus lambda. So now we have to find the variance. So variance of x becomes this minus lambda whole square. This gets cut, this gets cut, so variance is also x. So we find out that our expectation is equal to our variance, which is also equal to our lambda. So we actually could have found out that variance and expectation in both the cases are just the same, nothing but lambda. Let's also see something very interesting, like how, and this is very important in perspective of machine learning, so I'll do this. It's how can I convert a binomial into a Poisson. Okay, so binomial pi. What is pi? n minus I factorial by I factorial p to the power I 1 minus p to the power n minus I. Okay, so let's do something. We will do some approximations. Okay, approximations. First approximation, n tends to infinity. Second approximation, p tends to epsilon, which is a very very small value, means this is very close to 0. And 3, lambda is equal to np, which is a constant. Okay, these are our approximations we have to consider. We knew lambda was np, now we'll consider that to be constant, and it will be some good value, it won't be like very negligible. So we can do n factorial by n minus I factorial. We can do this by, we can substitute this like this. Wait, yeah, so after substitution it becomes something like this. Okay, now let's solve this a bit. So n minus 1 till n minus I plus 1 by n factorial. Okay, so not n factorial, so n to the power I substitute this here by I factorial. I'm just exchanging this with this. Okay, and I just cancelled this with this, nothing else. Okay, and here it will become 1 minus lambda by n by 1 minus lambda by n I. So it's just like converting this to a simpler form. Okay, now this term, since lambda is constant and n is very like large, this term and this term becomes in this form 1 minus 1 by x to the power x, where limit x tends to infinity, and this value is nothing but e So if there was a lambda here, for example, so e to the power minus lambda, it's usually e to the power minus 1. So whatever the constant is here, it gets substituted here. So e to the power minus lambda. And this whole term, since this is a very huge number and there are I number of this, so this gets cut and this is very close to 1. So, and this value is also close to 1 because this value will be very small, and 1 to the power something is 1. So what we can finally do is something, this term becomes e to the power minus lambda. So e to the power minus lambda, lambda to the power I by I factorial. This is what? Poisson random variable. So from binomial we found Poisson random variable. So with these approximations, so this is a very interesting result that you should know. Now we all were discussing about discrete random variables. Now let's move on to more continuous random variables. So like how they function and the basic things of continuous random variables. Okay, continuous random variables. Okay, so basically there we were using something called probability mass function. Now that will be changed to something called probability density function, PDF. PDF, let's say PDF I is nothing but from I to infinity fx dx. It's a very simple logic. Okay, so let's just say, let's do one sum. So let's say there is fx and fx is c 4x minus 2x square 0 to 2 else. Okay, now tell me what is the value of c. Okay, what is the value of c? We know a probability will always be 1 max, matlab for anything. So 0 to infinity of fx dx will be 1. Okay, so 0 to infinity of 4x minus 2x square dx. So this part, okay, so this part is from 0 to 2, and for other parts 2 to infinity it's 0 dx. This has to be 1, so this is 0. So you see here, so c into, let's say, 2x square minus 2x cube by 3, and this is from 0 to 2, this is 1. So c into 8 by 3 is equal to 1. C's value comes out to be 3 by 8. So this is how you, these kind of sums are very common. These kinds of sums will come a lot where you have to solve all of them. So remember this. Okay, so yeah, so also some few 2-3 notations I would mention, like this. Let's say this is the probability function graph, and if I say what is the probability of, let's say, x less than a. Okay, so you have to just do this, draw a line A here, and this area from, so this is from minus infinity to a. This is your area you have to cover. So now let's say if I give you probability of a x b, right? So let's say this is b, so this area is the concern, so this will be from a to b. Alright, so this is how you can understand a few things which I have explained. These kind of sums are very common and you will be asked a lot. So like in this case, like expectation is what? Minus infinity to infinity xpx. Okay, so let's say if I have a function, let's say 2x from 0 to 1 and 0 else, right? So what is the expectation? Expectation will be x of x. So it will be 0 to 1, 2x square dx. How? Why is it 2x square? Because this is the probability mass function into x. So 2x into x is 2x square. So this will be what? 2 by 3. Yeah, 2 by 3, 2 by 3. So this is how you need to compute these kind of sums, and yeah, try to just do this kind of sums. These type of sums will come a lot, so try to do it in this manner whenever you're doing like e to the power x ex. This is how you have to tackle these kinds of sums. Now for variance, everything remains same. You don't need to learn anything different. Just calculate it at the same way, like just e to, so here ex square would be what? Integration x square fx. So calculate this, then just do ex square minus ex whole square, and this is your variance of x, right? So this is very easy. I think I skipped this earlier. Standard deviation is nothing but the root of variance of x, but I think I had skipped that before, so I just mentioned it right now. Now we will talk about some good continuous random variables which you have in the syllabus. So the first thing is uniform random variables. Uniform random variable, just tell ki, let's say there is an interval a b, right? So if it is in an a b, so fx is equal to 1 or 0. 1 when it is inside this range, or else it is 0, right? So so this is the main definition of this. So how do we verify if this is a probability distribution function? Like if it's a valid PDF, we do integration fx is it 1. So integration a to b, right? So we need for, so this case you see, right? This case is not for this specific case. I said it wrong, sorry. So this case is only for 0 to x, but for, let's say we need to make it 0 to 1, it should be let's say c dx is equal to 1, right? So what would be the value of c, right? So c has to be something like b minus a is equal to 1. So c's value has to be 1 by b minus a. So our updated f of x should be something like, so 1 by b minus a or 0. So between a, b or else, right? So this should be our updated thing. So the graph is something like this. Okay, so this is between a, b, and this thing is nothing but 1 by b minus a. Okay, so of course the first thing we must do is ex. What is e of x? It's very simple. Integration minus infinity to infinity x of x dx, right? So I'm not writing the limits, so it will be x by b minus a dx, and we are just going to consider from a to b, because rest of the places, like rest, it is just 0 dx, right? So it's 0 only. So this will be what? B minus a. So sorry, not b minus a. So this will be what? X square by 2, 1 minus b minus a. This is from a to b, right? So this comes out to be b square minus a square by 2 into 1 minus b minus a. This is nothing but a plus b by 2. So now let's find variance. For variance we have to do ex whole square, sorry, ex whole square. So this will be integration alpha square, not alpha, sorry, integration a to b x square by b minus a dx. So this will be x cube by 3 1 minus b minus a to b. So this comes out to be, if I'm not wrong, the form, you know, it will be b cube minus a cube by 3 into b minus a, but I think the formula will be something like a square plus b square plus ab by 3, if I'm not wrong. So now the variance, right? So the variance would be nothing but this thing, a square plus b square plus ab by 3 minus the square of that thing, that was a plus b whole square, right? So this would be a square plus b square plus ab by 3 plus a square, sorry, minus a square plus b square plus 2ab by 2. Okay, so that comes out to be a square plus b square minus 2ab by 12. Okay, this will not be 2, this will be 4, sorry. And finally this is what, a minus b whole square by 12. So we find out that e to the power ex is nothing but a plus b by 2, and variance of x is nothing but b minus a whole square by 12. For this is for uniform. Okay, now we'll end this here today, and on the next day we have 2 more left, that is exponential and the normal. So exponential is okay, not that difficult like this uniform thing, but normal is the single most important thing. If you don't understand this, you will not understand anything. So this thing is something we have to focus a lot on it, and this will take 90% of our time. So we have to focus a lot on this normal thing. So we'll end the lecture today. Thank you for listening.